Welcome back to our tutorial. In this particular one, we'll commence the homology modeling. If you haven't watched our introduction on what is homology modeling, you can refer to our previous video for that. To do that, I will simply log into one of our resources or database we use for homology modeling. I will input uniprot. Simply type uniprot.org. Okay, or simply uniprot. It will navigate you or take you to the page. So I'll hit enter. Okay, it's trying to load. Remember, while working with databases, you need to be sure you're connected to internet, and a strong one indeed. So this is what I have. Okay, this particular protein I want to model. I have the uniprot code. Okay, every protein, once the sequence is known, will always have what? A uniprot code, okay, or uniprot ID. Search for the uniprot ID, or if you wish to search with the name, you can use the name, only that the name will expose you to several options, okay? But once you have the ID will take you specifically to that particular protein of interest you're talking about. So this is the protein I want to model. The uniprot ID is P61851. Okay, P61851. So I'll search for this protein. Okay, it's loading. Okay, it has loaded. This is my protein. Okay, and this is the code P61851. Is a what is a superoxide dismutase. Okay, from Drosophila melanogaster. Okay, that's the protein I'm looking for. Then it's very important, once you get your protein, or once you navigate your protein. As you can see, this is the information that Uniprot can provide for you. If you scroll down, or by this left side, you will see different information about this particular protein. One of it is the structure. Okay, why am I actually trying to model this protein? It's simply because I don't have the crystallized structure yet in the database, be it PDB or Uniprot and the rest. So what do? I'll need to check the structure here to actually see if this my protein actually have structure or not. So I'll simply go and click on the structure, or you navigate down by using your arrow button. You can scroll down and you still get down to this particular structure. Okay, so this is what I have, is trying to load to search if this my protein actually has structure. If it has structure, I don't need to model it. But if it doesn't have structure, I will have to perform modeling. Okay, it's still loading. Okay, it has loaded and it has brought out this particular structure. Okay, but I need to be sure what this structure actually means. Does it mean this structure has been crystallized either via X-ray crystallography or EM or NMR? Okay, electron microscope or NMR. Okay, below the structure, you will see the source, you will see the identifier, you will see the method of bringing this particular protein, or what we call method of extraction. Okay, is it via X-ray or via NMR or via electron microscopy? From what you can see, this is simply a predicted structure, or what we call a model. Okay, somebody has modeled this before and have uploaded his or her modeled result. Okay, and you now see this here. So this is not actually an X-ray, or what we call a model. So as a result, I may decide not to use this predicted structure. I need to predict my own, okay, and make my own meet my own condition before I can pick it. So this is simply why I can't use this particular protein. The structure has not been elucidated. Take for instance, let me show us what I mean. This is another protein. Okay, this is another protein. This is albumin. Okay, this is albumin. This is albumin 02768. Okay, but this, let me go to the structure and show you. This is the structure. This is telling me that it has a structure too. Then under method of elucidation, you can see X-ray crystallography. These structure have been what crystallized using X-ray crystallography. So in such case, I don't need to model this kind of protein again, because the structure has already been elucidated and uploaded in the what in the database, and you can use PDB format. Look at the PDB format, you can download it there. So this is already known. But for my own dismutase, the structure is not yet known. So it was only predicted or modeled. So in this particular tutorial, we're going to make use of this particular protein as we continue in our modeling. To simply get the structure of this particular protein of interest, which is this dismutase I'm looking for, okay, this particular I need the sequence for the modeling. I'll simply go down, scroll down, or simply come by the left side. You will see sequence here. It's either you click on sequence here, or you simply scroll down, I think close to the last. Okay, you will see sequence. You can see this black arrow is already in the sequence, telling you what is in the sequence section you are. Okay, in the sequence, this is the sequence I have here. Okay, this is the sequence. It started from 1 to 153. Okay, that is this length you are seeing here. Okay, that is this length you are seeing here. Okay, what do? I will need to get this sequence. I will simply do that by what? Clicking on this download. Okay, you can see the option for download. To download this, I'll simply download the sequence or the faster sequence of this protein. So I'll simply click on download. Okay, this is my what? My sequence. Okay, this is my sequence. You can see that it's superoside dismutase from Drosophila this. Okay, so this simply means the sequence. I'll simply copy this sequence and save it in my notepad or wherever you want to copy it. But this is the sequence you're going to be working with in the course of the what? The modeling. Thank you. In the next video, we'll continue with the modeling process. See you there.